This is the brief on neural tube defects and their prenatal biomarkers. For high-risk pregnancies, like when a mom is 35 or older, doctors will often use a procedure called amniocentesis to hunt for tiny chemical warning signs that the fetus's nervous system hasn't safely sealed up. First, let's talk about how this actually starts. Right around the fourth week of development, the edges of the neural plate are supposed to fuse together. Think of it kind of like a sleeping bag being zipped up from the middle toward both ends. Now, if that top zipper gets stuck, which doctors call a rostral failure, it leads to an anencephaly. And if the bottom, or caudal zipper fails, well, that results in spina bifida. Second, we've got to look at the fallout of that failed fusion because it leaves a permanent gap right between the neural tube and the amniotic cavity. So what happens when this delicate system stays open? Well, fetal cerebrospinal fluid literally starts leaking directly into the amniotic fluid around the baby, which, by the way, is otherwise mostly just fetal urine. Finally, how do we actually catch this leak? We look for specific biomarkers. A protein called AFP, or alpha-fetoprotein, spills out and can even cross the placenta, spiking levels in the mother's blood. But the absolute smoking gun? That's an enzyme called acetylcholinesterase, or ACH. Normally, this enzyme is safely locked away in the spinal fluid, so finding elevated ACE during an amniocentesis is absolute proof that a leak has occurred. Ultimately, an unzipped neural tube lets these hidden cerebrospinal proteins escape, giving doctors a perfectly clear, definitive chemical alarm bell.